So one last question we might want to ask about the Fourier transform is when does it exist? For which functions, gt, which time domain signals, does the Fourier transform exist? So let's go back to the example that we looked at in example 3.1, where we were looking at a time domain signal e to the minus at ut, and we applied the definition of the Fourier transform. Now, if you remember, when we applied the definition, we were working through the analytical definition, and we got to the point where we had to evaluate the integral. And at this point, if you don't remember this, just look in the previous video, but we were evaluating the integral, and we plugged in infinity and 0. And if you look at this, you can see that for this part of the integral, when we are evaluating it at infinity, we said, well, we'd better make sure that a is greater than 0 so that we can get a result. However, if a was less than 0, we would not have been able to get a result for GF. We would not have been able to find the Fourier transform. So we can guess now from this that sometimes the Fourier transform does not exist for some time domain signals. And we can see that this one doesn't exist for our example because, right, if a had been less than 0, then when we tried to evaluate that part of the integral, it would have been equal to infinity, and therefore the Fourier transform we wouldn't have been able to evaluate. So for certain values of a, we would not have been able to have the Fourier transform exist. So maybe we can come up with a way to, or an expression to say when the Fourier transform does not exist. So sometimes it can't be found. However, we can guarantee that the Fourier transform will exist if our time domain signal satisfies this expression. So if the absolute value of our time domain signal when integrated from minus infinity to infinity is less than infinity, we can guarantee that the Fourier transform will exist for that time domain signal. And if this condition above is satisfied, we can say that the time domain signal gt satisfies the Dirichlet conditions. So if the signal satisfies that equation, we can say for sure that the time domain signal does have an actual Fourier transform. However, there are some time domain signals that do not satisfy that equation that do have a Fourier transform. But all time domain signals that satisfy that do have a Fourier transform. So in some examples later, most notably, the signal sine of t over t would not satisfy this equation. However, it does have a Fourier transform.